Okay, today we are beginning Unit 13, our final unit in coordinate algebra. We're going to begin this unit with a review of something you should have already seen called the Pythagorean Theorem. Okay, so we're going to do a little bit of review first. Okay, if we have a right triangle, a three-sided figure that contains a right angle, okay, the two sides that make up the right angle are going to be called the legs, okay? And we're going to give one of them the letter A, one of them the letter B. It does not matter which one you choose, okay? All right, and then there's going to be the one remaining side that is across from the right angle, not one of the sides that makes up the right angle. That longer side across from the right angle is called the hypotenuse, and we assign it the letter C. Okay, so the Pythagorean theorem states that if you square one leg and add it to the square of the other leg, it will always equal the hypotenuse squared, or in other words, a squared plus b squared equals c squared. Okay, now let's review one more thing before we get started working on some examples. Okay, if you had to solve this equation, x squared equals 9, ultimately our goal is to get x by itself so that when we're done, we can say, okay, this is something you could plug in for x to make this true. So we want to get that x by itself by getting rid of the squared. Every mathematical operation has an inverse operation. Well, the inverse of squared is square root. On the left side, the square and the square root are going to undo each other, and that will just leave us with the x that we wanted. On the right, we're asking, what is the square root of 9? What number can you square to get you 9? Okay, we typically would say 3, which is half correct. But if you think about it, if you're looking for a solution to the equation x squared equals 9, there's actually another solution. If x squared equals 9, x could be 3, or it could be negative 3. Now, the good thing is about the Pythagorean theorem, what we're ultimately solving for is the leg of a right triangle, one of the sides of a right triangle, so it couldn't be negative. So we actually kind of got saved by not needing to know that about the plus or minus that we could put in the front. We are able to just say 3. Okay, when we move to the next one, if x squared equals 9, still, again, our goal is to get x by itself. Get rid of squared by doing a square root. Okay, the square and the square root undo each other. They're inverses, so we're left with just x. Now, unlike the square root of 9, okay, we were able to say the answer is 3 or negative 3 because we know that 3 squared is 9. We don't know of a whole number that you can square to get 10. There is no whole number. So when we have something like this under the radical, like 10, where it's not a perfect square, then we say, okay, we can leave our answer as the exact number, the square root of 10, or we can get our calculator out and say, well, it would be about 3.16. Okay, every radical that's not a perfect square underneath is going to be what we call an irrational number, a decimal that goes on forever without repeating, and so we're going to have to round those off, and they will tell you whether to round to 1 decimal place, 2 decimal places, or whatever. Okay, so let's look at some examples with the Pythagorean theorem. Okay, first thing I would like to do each time, if you need to, is label which sides we're going to call A, B, and C. Okay, in this case, okay, the unknown is the hypotenuse. I'm going to call it C, and I can choose for either one of the two legs. One of them's A, one of them's B, and it doesn't matter which is which. Okay, the same thing will work out if you switch them and use the other way. All right, so I'm going to write down the Pythagorean theorem. A squared plus b squared equals c squared. Okay, I'm going to substitute in the numbers I know. In the place of A, I'm going to put 6. In the place of B, I'm going to put 8. C is my unknown, so I'm just going to leave it a variable. And when I substitute in a number for a variable, I like to put the number in parentheses just to set it off in case there are occasions when you really need the parentheses. So I like to just always make that a habit. Okay, on the left side, I'm able to do some simplifying. I know that 6 squared is 36. I can evaluate that. Evaluate 8 squared and get 64. Okay, that side can be simplified a little bit more. I can go ahead and add 36 and 64 and get 100. Okay, now I'm back where I was a moment ago. I'm trying to solve for C. Okay, the way that I get rid of that squared is to take the square root. Okay, so that will leave me with just C. Now, it asked me in the directions to give my answers two ways, a radical And also to round to one decimal place if necessary. Well, I don't have to round this time. I know of a whole number that I can square to get 100, so I know that the square root of 100 is actually 10. So those are the two forms for the solution to C, the hypotenuse, the square root of 100, or 10. Okay, moving on to number 2. Again, the unknown is the hypotenuse, so that'll be C. Okay, choose the legs. Which one will be A, which one will be B? It doesn't matter which is which. Write down the Pythagorean theorem if you need to. Okay, plug in what you know. 5 squared plus 7 squared equals C squared. Okay, I've got a lot of simplifying I can do on the right. 5 squared is 25. 7 squared is 49. Okay, go ahead and add 25 and 49. That's 74 equals C squared. Okay, now I'm ready to get rid of that squared by taking the square root of both sides. So C equals square root of 74. Now this time 74 is not a perfect square, so I'm going to go to my calculator and do the square root of 74. Okay, the directions told me to round to one decimal place for these. Okay, so I'm going to use my calculator and get that the square root of 74 is about 8.6. Okay, so those are my two solutions for that side. Okay, number 3. Now this one's a little bit different. Okay, if we look at the hypotenuse, it's actually something I already know. C is 13. Okay, now I tend to, if one of the legs is the unknown, I tend to make that A. You don't have to, but it kind of helps out with the equation solving. Okay, all right, so I've got my A, my B, and my C. Let me copy down the Pythagorean theorem. Okay, A is my unknown, B is 5, C is 13. Okay, I'll simplify a little bit. Evaluate 5 squared, 25. 13 squared is 169. Okay, now this is a little different this time than the other two that we worked. This time the 25 and the 169 are on opposite sides. And we know that ultimately my goal is to get that A by itself. So before I worry about taking a square root, I need to get rid of that plus 25 by subtracting 25 from both sides of the equation. The subtraction property of equality says I can subtract any number from both sides. Now I'm ready to take the square root of both sides. So I get A is the square root of 144. 144 is a perfect square because it's 12 squared. So my two answers are the square root of 144 or 12. Okay, number 4. Okay, hypotenuse is known. I like to make my unknown A. You don't have to. You can make it B. Most people tend to do a little better if they make the unknown the A. So A squared plus B squared equals C squared. A squared plus 4 squared equals 10 squared. A squared plus 16 equals 100. Subtract 16 from both sides. A squared equals 84. Now we can take the square root of both sides. So A is the square root of 84. Go into my calculator. I know it's going to be a little over 9 because 9 squared is 81. And it is 9.165. So if I round to one decimal place, it will be 9.2. Square root of 84, approximately 9.2. Okay. All right, let's quickly work through these last two, C, A, and B. As you go through this, you should be able to get a little quicker and maybe even be able to skip some steps as you go. A squared plus 7 squared equals 12 squared. A squared plus 49 equals 144. Subtract 49 from both sides. A squared equals 95. Take the square root. A is the square root of 95. Okay. Again, it's a good idea to predict about how big you think your decimal should be. Since 95 is a little under 100, my answer should be a little under 10. Okay, using my calculator, I got 9.7, which is in fact a little bit under 10. Square root of 95, about 9.7. And finally, okay, hypotenuses are unknown this time. So a squared plus b squared equals c squared. 6 squared plus 11 squared equals c squared. 36 plus 121 equals c squared. Both constants are on the same side, so we can go ahead and add those together. And then take the square root of both sides. Okay, should be a little bit over 12. 12.5. Okay, all right. Now we're going to use this in the coordinate plane. Okay, we're going to plot the points, we're going to draw the lines to form a right triangle, and we're going to use the points at the end of the hypotenuse. Okay, now the beautiful thing about counting in the coordinate plane, if it's horizontal or vertical, you can just count the blocks, and that's what we're going to be able to do here with these. Okay, so for example, okay, if I wanted to know the distance between the points 2, 4, and negative 2, 1. I want to know the straight line distance between these 2 points. Okay, so what we're going to do is draw some horizontal and vertical lines to complete a right triangle. All right, we're going to count on the bottom. Along the bottom, we have 1, 2, 3, 4 blocks. Okay, on the side, we have 1, 2, 3 blocks. Okay, so if I let this be C, A, and B, A squared plus B squared equals C squared. 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. Same side, add them together. Take the square root of both sides. C equals the square root of 25, which is exactly 5. Okay, all right. And you need to ask your teacher about Pythagorean triples, because that 3, 4, 5 is significant. Okay, find the distance between these 2 points, negative 4, 5, and 3, 2. Okay, we want to find the straight line distance between these 2 points. Okay, we're going to make this so that that segment there becomes the hypotenuse of a right triangle. Okay, counting along the blocks, 1, 2, 3, 4, 5, 6. Nope, 7, sorry. Okay, and then the side, 3. Okay, and then we can do the Pythagorean theorem, a squared plus b squared equals c squared, because that segment that we're looking for became the hypotenuse, and the other 2 will always be the legs. 3 squared plus 7 squared equals c squared. 9 plus 49 equals c squared. So 58 equals c squared. And then if we take the square root of both sides, we'll get the radical square root of 58. Calculator will give you that that is about 7.6. Okay, one more. All right. Calculate the distance between negative 3, negative 4, and 5, 3, and then tell the area and perimeter of the triangle. Okay. All right, we have negative 3, negative 4, and 5, 3. Okay, I'm going to calculate the straight line distance by making this into a right triangle. Okay, right triangle here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 here. So the hypotenuse C, A and B. All right, A squared plus B squared equals C squared. 8 squared plus 7 squared equals C squared. 64 plus 49 equals C squared. 113 equals C squared. Take the square root, and that will give us that side, that hypotenuse, is the square root of 113, or about 10.6. Let me label that. I now know that C is the square root of 113, or approximately 10.6. Okay, so think, how do we find the perimeter of any polygon? Well, we just add the sides together. Well, I had 8 and 7 that I could find by counting, and then I have this other one, square root of 113, or about 10.6. So if we leave it as an exact answer, it would be 15. That's the 8 plus 7, plus that radical, square root of 113. Or if I could use a decimal approximate, I can just add the 8 and the 7 and the approximately 10.6 and get approximately 25.6. All right, finally, the area. Okay, just as a reminder, the area formula for a triangle is 1/2 times base times height. Okay, the base of this triangle is here. This 8 is the base. The height of the triangle then is this 7. So if I do 1/2 times 8 times 7, okay, multiply any two of those together, and then I'll multiply that by the third one, and we'll end up with an area of 28 square units. Okay, that's it for today's introduction. Tomorrow we're going to continue a little bit more with Pythagorean theorem.